We hear it all the time, right? Artificial intelligence is going to completely change healthcare. It's going to mean faster, more accurate diagnoses, personalized treatments, the whole deal. But here's the thing. If you look at the people on the front lines, the actual doctors and nurses, they're not really using it. There's this massive disconnect between the promise of AI and what's actually happening in the clinic. So let's get into why. So just how big is this gap? Well, get ready for this. According to research, we're talking about only 10 to 30%. That's it. That's the percentage of doctors who are actually using these sophisticated AI tools in their day-to-day work. It's not just low, it's kind of wild when you think about how much hype is out there. The vast majority of this revolutionary tech is just being left on the table.
You gotta ask, what are we all getting so wrong here? I mean, the technology is supposed to be brilliant, so why the hesitation? Why are doctors, the very people this is supposed to help, so reluctant to adopt it? Well, the answer is fascinating, and it has almost nothing to do with how smart the AI is.
And here is the single most important insight from the systematic review we're digging into today. The problem isn't the algorithm. It's not about needing a more powerful model or a bigger data set. The real issue is our entire approach. For years, we've been focused on the technology when we should have been focused on the human who has to use it.
So if we want to fix this, the research boils it all down to two critical concepts. Two keys that unlock trust and ultimately adoption. They are explainability and integrability. You get these two things right, and suddenly AI starts to look a lot less like a threat and a lot more like a partner. So what do those words even mean? Let's make it super simple. Explainability is all about the why. Can a doctor look at an AI's recommendation and understand the logic behind it? It's like in school when your math teacher said, show your work. Same idea. Then you have integrability. That's the how. How does this tool actually slot into a doctor's incredibly complex and stressful day? Does it make their life easier, or is it just one more click?
All right, let's dive into that first pathway, explainability. And let's be crystal clear about this. This isn't some nice optional feature. For a clinician who is responsible for a patient's health, maybe even their life, understanding the why is an absolute non-negotiable requirement. What's really interesting is that doctors don't want a 50-page technical manual. The research is very clear. They want something very specific called post hoc local explainability. Now that sounds complicated, but all it means is give me an explanation after the AI has made its call and make it about this one patient I'm looking at right now. Not a general theory, but specific facts for a specific case.
And this diagram from the study shows it perfectly. You see those three stages? The AI developers might be obsessed with the first two, the data inputs, the model's internal wiring. But the clinicians, they live and breathe in that third box, post-processing. The only question they really care about is, okay, what did the tool find for my patient and why? So what does a good explanation actually look like in the real world? It's about answering the questions a doctor's already asking in their head. Questions like, which of this patient's symptoms or lab results did you actually find important? How sure are you? Give me a confidence score. Can you pull up a few similar cases so I can see the pattern? And please, can you show it to me visually with a heat map or something simple? And by the way, where did this data come from? Is it reliable? And this quote from one of the papers just says it all. Forget complex charts and graphs. Doctors need simple, fast, intuitive cues. They wanted visual indications of severity, such as red, yellow, and green, paired with a numerical indication. We're talking about a traffic light system. It's something you can understand in a split second. That's how you build trust.
Okay, so let's say you've nailed it. You have a perfectly explainable AI. The doctor trusts the why. But that's only half the battle. Now we have to talk about the second key, integrability. Because even the most trustworthy AI is totally useless if it's a pain to use. It has to fit the workflow, not fight it. This framework breaks it down beautifully into 3 pillars. First, there's the workflow itself. Does the tool pop up at the right decision-making moments? Second, system compatibility. Does it play nice with the other software the hospital uses, especially the electronic health record? And third, just plain old usability. Is it easy to use, or does it feel like you're trying to land a spaceship?
And digging into that workflow piece, the research gives us 3 golden rules. 1. Provide support at critical decision points, not during routine charting. 2. Avoid alert fatigue. Doctors are drowning in notifications. Every single alert from the AI has to be meaningful. Otherwise, it just becomes background noise. And 3, and this is so important, the AI's recommendations have to be practical and resource aware.
And this quote, this is just a perfect, painful example of what happens when you get integratability wrong. This AI system, used in rural clinics, kept suggesting lab tests and medications that the clinic literally did not have access to. Can you imagine how quickly that tool becomes useless? It's not just unhelpful, it shows that the AI is completely disconnected from the user's reality. So, of course, the recommendations get ignored, and trust just evaporates.
So we've diagnosed the problem. We know the two main causes are a lack of explainability and integratability. But how do we actually solve this? The good news is, the paper provides a clear, actionable roadmap for anyone trying to get this right, whether you're a hospital leader or an AI developer.
It's called the EPIS framework, and it's a 4-step plan. Step 1, exploration. Simple, but radical. Actually talk to clinicians before you build anything. Find out what they really need. Step 2, preparation. This is where you wrestle with the tech integration issues and design the simple explanations we talked about. Step 3, implementation. Don't flip a switch overnight. Roll it out slowly in phases. Start with low-risk tasks, get tons of feedback, and iterate. And finally, step 4, sustainment. An AI model is not a set-it-and-forget-it product. You have to constantly monitor it, update it, and be transparent with users about those changes. And that really brings us to the final, bottom-line question. It's a question that every leader in this space should be asking themselves. Are you building a trusted colleague, a tool that makes a clinician's job easier and their decisions better? Or are you just building another frustrating system that they have to find a workaround for? Because the answer to that question will define the future of AI in medicine.